All right, we're going to take a look at some word problems involving scientific notation. And I know throughout this lesson it says that it doesn't want you to use a calculator, but we're going to use a calculator for some of these calculations. We're not going to be doing decimal operations by hand. That's just going to take too much time. So the first question, 100, says a typical dwarf sperm whale, the planet's smallest whale species, weighs about 3 times 10 to the second pounds. A blue whale, the planet's largest whale, might weigh about 4.5 times 10 to the fifth pounds. Estimate how many times heavier the blue whale is than the dwarf sperm whale. And we are just going to pretend that it doesn't even say without a calculator. Okay, so we're going to take the amount of pounds that the heavier whale is, the blue whale, and we're going to divide it by the weight of the sperm whale. Okay, so this is what it looks like, and what we're going to be using the calculator for is this portion. I want to know what 4.5 or 4.5 divided by 3 is. So if you do it on your calculator, it comes out as 1.5. For the other side, we are not going to be using a calculator. We're going to simplify using our laws of exponents. So if I have two exponent values that are being divided, the shortcut is to subtract the exponents. So 5 minus the 2 gives me 3, I hope you said. So the answer to this question is 1.5 times 10 to the third, or it's about 1,500 times larger. 101 says there are about 1.8 times 10 to the 21st molecules in 1 gram of table sugar, which is C12H22O11. Carbon 12, hydrogen 22, and oxygen 11 is what that stands for. A baker uses 8 times 10 to the second grams in her recipe for cinnamon pastries. And in this question, we're only going to be looking at A. How many molecules of sugar does the baker use? So if this is the amount in 1 gram, and this is how many grams she uses, we're going to be multiplying. So 1.8 times 10 to the 21st power times 8 times 10 to the second. Now, the part I'm going to use the calculator for is to multiply 1.8 times 8. And that gives me 14.4 times 10. And if I have an exponent here and an exponent here, and I'm multiplying, they're the same base, I add the exponent. So 21 plus 2 gives me 23. But wait a second. This number is not in correct scientific notation form. It needs to have the decimal point between the 1 and the 4. So it looks like 1.44. And because I'm moving the decimal point to the left, I'm going to be adding a value to my exponent. 102. And for this one, we're just multiplying. So 1.75 times 6.01 gives me 10.5175. And this exponent is to the 20th, and this is to the 14th. So 14 plus 20 gives me the exponent of 34. Just like the last question, this value is not in correct scientific notation. It needs to be a number between 1 and 10, and this number is higher than 10. So this decimal has to move over one spot. So I would have 1.05175 times 10 to the, I'm moving it up over, so I need to have it to the 35th power. And the second part of the question says, write down what your calculator says. We're not actually going to put it in the calculator. Okay? 103. The average distance from the sun to the earth is 1.488 times 10 to the 11th meters. If the length of the average paperclip is 3 times 10 to the negative second, how many paperclips would need to be connected together to reach the sun? So this is like the first problem. We're going to divide. Taking the distance from Earth to the sun and dividing it by how many paper clips we might need. So 1.488 divided by 3 is your first step. And that's going to give you 0.496 times. The second part is looking at the two exponents, and when we have division, we subtract them. So 11 minus negative 2, keep change, is 13. Okay, so this is 10 to the 13th power. But look, our number's not in correct scientific notation. Our number's not in correct scientific notation. This decimal point needs to move one place value to the right between the 4 and the 9. So I'd have 4.96 times 10, not to the 14th. Last time we added because we moved the decimal to the left. This time we're subtracting from the 13 to get 12 because we're moving to the right. I didn't like the next question at all, so we're going to skip it. I know I put it in here, but I didn't like it, so we're taking it out. 105. The United States Department of Agriculture reported in Vegetables and Melons Outlook in 2007 that the average American consumes 7.4 times 10 to the third potato chips a year. Since Idaho has about 1.5 times 10 to the sixth people in 2007, how many potato chips would each Idaho resident have consumed in 2007? So it's saying that the population is 1.5 times 10 to the sixth, and on average, each one of those people consumes 7.4 times 10 to the third potato chips per year. So we're going to be multiplying these together to find out how many potato chips they ate altogether. So 1.5 times 7.4 gives me 11.1. And then we have our exponents, right? 10 to the sixth and 10 to the third. When we multiply, we add those exponents. So this will be 10 to the 9th. But wait, what's wrong with this? Same thing that was wrong with the other ones. This number is not in correct scientific notation. The 1 should be the only leading value in front of that decimal. So we need to move it over. So it would be 1.11 times 10 to the 10th. Okay, we went to the left, so we add that. 106. Last one we're looking at. One of the giant pyramids of Egypt is made of 2.4 times 10 to the 6th carved blocks of stone. If each block weighs approximately 4.95 times 10 to the 3rd pounds, how many pounds of block make up the pyramid? So 2.4 times 10 to the 6th. What do you think we're going to be doing? We're going to be multiplying. 4.95 times 10 to the 3rd. Okay, so 2.4 times 4.95 gives me 11.88. 10 to the 6th and 10 to the 3rd, when we multiply them, we add the exponents, so it would be 10 to the 9th. And just like the other ones, the first number is 11, which is higher than 10, not in the correct formation for scientific notation, so I need to move the decimal over 1. So I have 1.188 times 10 to the 10th. Because I moved to the left, I add it to the 9.